So for our first challenge exercise, we have count, which will print out all the numbers between start and finish. So I'm going to take it inclusive. So if start is 3 and finish is 5, we're going to count 3 and 5, not just print 4. So we can do this with a for loop or a while loop. First thing I'll show is a for loop. So we would need to start our counter, and since it's everything between start and finish, let's say inclusive, we are going to start the counter at start. And for our condition, so this is the condition at which the code will actually continue past the for statement. Well, it's while I is equal or less than finish. So that means in between start and finish, since it starts at start. And we're going to increase it at every iteration of our loop. Inside, we can print out what I is. So since we're looping through every single number between start and finish and printing out each stage, we're going to print out all the numbers between start and finish, and we're going to check this by calling count, and let's say 4 to 10, hit play, and as you can see, count prints out 4, 5, 6, 7, 8, 9, and 10. So if this isn't inclusive, then I suppose we could start it at start plus 1, make it just is less than finish, and we print out everything between 4 and 10. And we could also do this with the while loop. So similarly, we're going to start a counter at start, then we're going to have it continue while I is less than finish. Make sure we increase I at every stage of the loop. And also, like before, print out I at every iteration of our while loop. So hitting play again, we should get all numbers 4 to 10. Brilliant. So for this challenge exercise, we're going to be filling in the function palindrome, which returns true if its given string is a palindrome and false if not. So a palindrome is a word that's read the same forwards as it is backwards. In other words, if you check what the first letter is and then check what the last letter is, they're going to be the same, and so on for every single letter. So the second letter is the same as the second last letter, and the third letter is the same as the third last letter. So, knowing that logic, how can we write code to figure out if a word is a palindrome or not? Well, we can consider a string like this like an array of characters, which means that we can do what we usually do with arrays, which is use loops to go through them. So I'm going to set up a for loop. You might want to use a while loop. So I'm going to make a counter. I'm going to call it front because it's going to be the front index as we're going to check from both sides. So we want to start from the beginning because we're going to have to check every single letter. And then we need our condition. Well, since we're checking every single letter, we could just do it until we reach the very end. But what we could also do is until we reach the middle, because as you know, we check both sides as we go on, which means that there's no point rechecking past the middle. And then finally, we can increase front so we can go one by one. Inside our loop, so at every letter, we're going to need a condition. So I'm going to set up an if statement here. And instead of checking if they are the same at this point, I'm going to check if they're not the same. If they're not the same, then it can't be a palindrome. One thing that doesn't match and it's out. So, to check if the word at our front is the same as its corresponding letter at the back, so if our letter at the front is the same as its corresponding letter at the back of the word, then it's not a palindrome. So, if my string front is not the same as my string, and this will be the back. But we don't have a variable for that, so we're going to use our front to calculate that. So for the very end, we're going to take the length, but as arrays start from 0, for the last one we're going to need to subtract 1. Since the arrays start from 0, it's going to be 1 less from the length. And we also remember that as front increases, you're also going to want the back to decrease. So we're going to subtract front. And if the letters are not the same, then it can't be a palindrome, which means we return false. So if it went through this entire for loop without returning false, therefore exiting the function totally, then it must have never found anything false. So it must be true, it must be a palindrome. So let's hit play. We should get true, true, and false. So this lines up as we got 2 truths for these two, and 4 for the rest. So these 3 are our bonus round exercises, which ignore spaces and case. So if you want to do that one, keep watching. Then I'm going to go to how to do it. So in this case, we're going to ignore the cases of these, and we're going to skip past spaces. So ignore cases and spaces. So by doing a quick Google search, I found a JavaScript function that allows me to make everything lowercase. Everything inside of it lowercase. So what this does is, if every string that is passed through here is turned into lowercase to be checked, then it doesn't matter about cases because they're always going to be the same case, which is lowercase. Then we're going to need a function, we're going to need a way to skip past spaces. So how we can do that is, this time I will actually make a variable for the back. So for the very last index, I'm going to use the length -1. And this makes it a bit easier, just while front is less than back. And we're going to need to check if front or back is at a space, and if it is, for it to keep moving either forwards or backwards. So while back is a space, we're going to want to move backwards so that it reaches a letter. And while front is a space, we are going to increase our front. And remember, since only the front is inside the for condition, only front actually increments. So we're going to need to decrement back, so it keeps going backwards at every stage of our loop checking. And we'll change this to be back. We can't use the same condition as before, because if front moves forward, then the back of the word might not be the same number of numbers forward as front was, so you can't use the same condition. We're just going to use back. I'm going to hit play, and I have done something wrong. Oh, there we are. So we need to find the value at back and not back itself. So, hitting play, we should get true for the last 3.
Let's work through the challenge called Sum of Multiples. Here, you needed to add up all the numbers less than n that are divisible by k, where n and k are the parameters for this function. So for instance, with this first call of the function here, we have n is 7 and k is 2. So we needed to add up all the numbers that are multiples of 2 that are less than 7. So we're adding 2 plus 4 plus 6 to give us 12. Now, whenever you have a problem where you need to add something up, a common way to solve it is to start with a variable that we can use to store the sum in. So then whenever we find a number that we want to add to the total, we can just add it to that variable. So let's do that. I'll make a variable called sum and equate that to 0 to start with. Now, I reckon we need a loop. Since our n and k is going to be different each time, a loop will let us check a number to see whether we want to add it to the total, then stop checking once we hit n. So let's write that loop. Let's do it as a for loop, and let's start from 0. And we only want to count up numbers that are less than or equal to n. Then let's count up by 1, so we're checking every number. Now, how do we do the check to determine whether or not to include a number in our sum? The trick here was to use a tool called modulus, or mod for short. This is an operator that simply gives us the remainder, so one number mod another number is the remainder when the first number is divided by the second. So if a number is divisible by k, then that number, mod k, will be 0. So we can use that as our if statement condition to check. So here, in this loop, I is just in every number that we're checking as we go through all the numbers that are less than or equal to n. Then we check whether that mod k is equal to 0. And if that's true, then it's a multiple, so we can add it to our total. Then finally, to wrap it all off, we just return sum. Cool, let's test our function. Awesome, we seem to be getting the numbers that we expected in our tests. But let's do another one just to be sure. So let's add up the numbers that are less than 3, that are multiples of 3. Less than or equal to, I should say. So this should only be adding up one number, 3, because it's the only number that is less than or equal to 3, that is a multiple of 3. And yep, our sum is just 3, and that's what we expect. So it seems like our sum of multiples function is working. This challenge needed us to make a function that gets a string and inserts dashes in between all the letters and numbers. Notice that the dashes only go in sandwiched between a letter and a number, so if there's a space, punctuation or nothing on the left or right hand side, we don't add in a dash. Like all of the challenge questions, there are lots of ways you could solve this, and I'm just going to approach it kind of like how I approached the Duck Duck No Goose challenge if you've done that. Basically, I'm going to use a loop to check every character in the string, then do a check with an if statement to see where to add a dash. Okay, let's start with that basic part of the code. Let's write my for loop. Much like an array, strings will also have indexes. So I can loop through each index of the string using an index variable and stop looping once we've reached the end of the string as indicated by its length. Now for the if statement. Okay, what do we want to put in the if condition? I'm actually going to pause writing the dashes function right now and write another function first that we can use inside our dashes function. It's going to be called isAlphaNumeric. And it checks whether a character that's passed in, C, is alphanumeric or not. That is, it's an uppercase letter, a lowercase letter, or a number. And those are all the characters that we're checking for sandwiches of in this challenge. So this function is going to return a condition that'll be either true or false. When you make extra functions like this to help you in another function, this is called making a helper function. Alright, so this function takes in C, the character. As this hint here described, we can check if C is a lowercase character by seeing if it's between lowercase a and lowercase z. And we can do this with our less than or greater than symbols. So let's do our first condition. So return if C is greater than or equal to a, and C is less than or equal to Z. So we have an and here because we want to make sure that it must be between A and Z. It cannot be outside of that range. So it can't be less than A or greater than Z. So that's to check if it's a lowercase. Now let's do the same thing for uppercase letters. Let's do an OR operator here so that we can check for any condition. So whether it's uppercase or lowercase, doesn't matter, either one is fine. So we can do pretty much the exact same check, but just with uppercase letters. Awesome. Finally, we've got to do it for the numbers, whether it's a digit from 0 to 9. Notice here that I've put quotation marks around the digits. This is because C is coming from a string, so technically it isn't a number, it's still a string. And remember that strings can be made up of all numbers too. So, now that we've got this helper function going, it'll be returning true on all the right characters. So now we can fill in our if condition. So it's checking for the alphanumeric sandwich. That is, if the current character we're looking at and the one directly after it is a letter or a number. Then we want to add a dash after the current one. So that as an if condition looks a bit like this. So is alpha numeric. So let's check if the current character is alphanumeric. My string I. So this is indexing into the string, giving us the ith letter of the string. So if it's alphanumeric, the current one is alphanumeric, and the next one is alphanumeric, so same thing, but indexing into the next index. Is alphanumeric, chuck that into the function as well. My string I plus 1. Cool, so there's our if statement check with our helper function. So finally, to get our result string out, instead of editing the original string, I'm going to make a new string and build it character by character. So let's start with an empty string. I'm just going to call it new string, and let's start with empty. So there's nothing in there, just quotation marks with nothing in it. Then, for each character in the string, I'm going to add it to my new string, because we want to keep all the same characters, we're just adding some new ones in. So new string equals the current character, which we'll just index into like before. Then I'll do the check and see if I need to add a dash after it. So if it passes this check, so the current character is alphanumeric and the next one is alphanumeric, then I will add a dash too. Then after all this, after the for loop, I will just print out the string. Alright, time to test. Cool. Those look like our correct strings. We have dashes where we want them, and no dashes where there's spaces or just one character by itself. Seems right. Nice. So, those of you still watching might have been wondering, say in this for loop when we get to the end of the loop, so where I is 1 less than the length of the string, we're looking at the last character in the string, so this A here or this B or this 0. What is my string I plus 1 going to be equal to in this iteration of the loop? Good question. If we console.log it, so let's console.log my string I plus 1. You can see that it actually comes out to be undefined, which just means that it doesn't exist, because when the I is equal to 1 less than the string, then we're looking at this last character, so there's no next character. When we try and index into it, it doesn't exist. So this actually still works for our helper function because these conditions that we wrote are all still not satisfied. So it remains false, which means it's not alphanumeric, which means there will be no dash added and it doesn't matter, but it's still a good thing to keep in mind.